Welcome to the Explainer. Let's talk about a wild idea. What if our reality isn't really real? At least not in the way we usually think about it. Today, we're diving into a mind-bending theory that suggests our entire universe is built not from matter and energy, but from a pure mathematical code. And this isn't just a code that describes reality. It is reality.
Okay, so let's jump right in with one of the biggest questions you can possibly ask. Is the universe this smooth, unbroken, continuous thing, or is it more like a super high-resolution screen made up of tiny, indivisible parts, pixels? Well, that's where this radical new theory comes in, the Sentience-Field hypothesis. And it lands firmly on the pixelated side of things. It proposes that everything we see and feel, all of it, emerges from a purely mathematical foundation. A universe literally built from these tiny, indivisible pixels of information. So, to really wrap our heads around this, we first need to understand the two fundamental spaces the theory talks about. Think of it as the raw material of the universe and then the finished product that we actually get to live in.
First up, you've got something called Hilbert space. Now, the best way to imagine this is like an infinite, untouched block of marble that contains every single sculpture that could ever be carved. It's this realm of pure continuous potential holding every possible state of the universe, all at once.
But the reality we actually experience, what the theory calls qualic space, isn't that infinite block. Nope. It's the finished sculpture. It's a specific, finite set of pixels that have been selected and carved out from all of that infinite potential. So this image really sums it all up, right? On the left, you have infinite potential. On the right are finite, pixelated reality. So what's the bridge between them? It's a mathematical process called Hardy-Ramanujan partitioning. Now, don't worry about the name. Just think of it as a cosmic sorting algorithm. It takes an infinite number and finds the most elegant way to break it down into a finite set of parts. It's basically how the universe chooses its pixels. Okay, but that begs a pretty huge question, doesn't it? Out of infinite possibilities, how in the world does the universe decide which pixels to select? What's the algorithm that's running our experience? Well, the theory proposes this one, single, incredibly elegant rule. The coherence-fertility principle. It's kind of like a musician composing a song. You need coherence, a stable rhythm, a consistent key, but you also need fertility, a new melody, something creative to make it interesting. The universe, according to this theory, is doing the exact same thing, constantly trying to balance structure with creativity. You can picture it as this constant cosmic balancing act. See, if you have too much coherence, the universe just becomes static and frozen, boring. But if you have too much fertility, it just dissolves into complete chaos. So the system is always trying to maximize both of these bars, creating a reality that's just ordered enough to hold together, but also complex enough to evolve and create brand new things. And this whole evolution thing, it happens in a kind of three-step dance. First, the system follows a predictable path toward being more stable. That's the deterministic drift. Then there's a random creative leap, a creative shift that explores new possibilities. And finally, the system settles into a new, more optimized state. And then the cycle just repeats over and over again. So we have our basic algorithm, balance, stability, and novelty. But here's the real kicker, the million-dollar question. What happens when you just let that simple code run for billions and billions of years? What kind of universe does it actually build? And this is where things get really wild. The output is, well, it's astonishing. The model claims this process doesn't just create a universe that looks a lot like ours, it claims it can derive the most fundamental laws and constants of nature from the ground up, from scratch. For example, when the model runs the numbers to find the most perfectly balanced, most optimized mathematical states, this is the number it spits out, 137.036. Now, to you and me, that might just look like a random number, but if you're a physicist, oh man, that's like finding a signature from the creator of the universe. It's the fine structure constant, a number that dictates how light and matter interact. It's one of the most fundamental constants in our reality, and this model claims to pull it out of pure math. And what this does is offer this incredible solution to something called the fine-tuning problem, this huge mystery of why our universe seems so perfectly dialed in for life to exist. This theory basically says, hey, it's not luck. A universe that can support life isn't some cosmic longshot. It's just the most statistically probable result of this mathematical balancing act. But this isn't just some philosophical thought experiment you can't touch. No, the Sentience-Field hypothesis actually makes specific, testable predictions that we could verify or prove wrong right now out in the real world.
So for example, down in quantum labs, scientists can check if exotic states of matter behave with the exact stability the theory predicts. They can hook people up to EEG machines and see if those sudden aha moments of insight match the specific patterns the model suggests. We could even find new things in our most fundamental quantum experiments, all predicted by this cosmic code. But here's maybe the most radical part of all. The theory claims this core principle, this balancing act, doesn't just stop at physics. If it's a truly fundamental rule of reality, it should apply to any complex system, from galaxies all the way down to us, to human societies.
I know, it sounds like a huge leap, but just think about it for a second. That very same coherence fertility principle could be a model for how we run our societies. It gives us a mathematical way to think about balancing a society's fertility, things like economic growth and innovation, with its coherence, things like environmental health and social stability. It could turn the art of politics into a problem of optimization. And that leaves us with one final, really provocative question. If the entire universe, and that includes you, me, our consciousness, all of it, is simply the output of a mathematical equation, then what exactly is the thing that's here to experience it? That's definitely something to chew on.